What is statistic? Statistic means we are collecting some data from a population and we want to survey those data. Okay, then we make a conclusion about the population. This is all about the statistic. So behind statistic, we will have a population. So collection of all data. In this course, we will consider only numerical data. I mean, quantitative data we will consider. Qualitative data we will not consider. Okay, only we consider the quantitative data. I mean, the data that can be presented in terms of numbers by using numbers. Okay. So I can take an example. So the weight of all monkey in the Amazon forest. So we want to survey the weight of all monkey in the Amazon forest. This job is really difficult. By practical, it is not possible to read or to find the weight of each individual monkey. It is really difficult, right? You can feel that. Alright. So then, how do we understand then the average weight of all monkeys? So maybe there are 1 million monkeys total in the Amazon forest. So it is really difficult to read the weight of each 1 million monkeys, right? So really difficult. So we need a better mathematical approximate, that better mathematical theory that help us to predict or guess the average weight of all monkeys in the Amazon forest. So how do we do it? For that, here we take the help of the probability theory. Okay. So for that we can define the sample. Sample means subset of population. And this we can do by hand. Maybe 100 monkeys we consider and we measure the weight of each 100 monkeys. Okay. So we have 100 data, right? But so let's say in our sample, let's say consider n monkey and their weights are basically x1, x2, xn. Okay, so we consider n monkeys on a particular region in the Amazon forest, then those monkeys weight we measure and say we getting the weights are x1, x2, xn in some unit. Okay, then you can calculate the sample mean. So that let's say divided by x1, that will be from some x1 over n. Take the sum of all weights divided by n. This is the mean of this data. Okay. Now, one thing you note here that if you consider the whole population of monkey, let's say this is the population, the collection of all monkeys, right? So it is a huge number. So therefore, we cannot find the weight of all monkeys in the Amazon forest because the number is huge. But we can take a sub collection of monkeys, then we can measure the weight, and then we get the mean of those sub collection weights, right? Oh, yeah. So that is basically exactly this. So now you can really think that this we can use as the approximate of the average value of whole population, right? I mean, all monkeys in Amazon forest is a huge number, but it will have an average value. So that average value we can approximate by, population average value we can approximate by the sample mean, okay, or sample average, right? So we can guess this. This is naturally we can guess, right? And mathematically this is true, and this correct, and this first given by the Bernoulli for the law of large number. What is that statement? The law of large number. So if you consider n data, x1, x2, xn, this is like a sample of n data, then if you consider the mean of those n data, it will be by x and y. So this is some sign of n, right? Then law of large number states that, so population has a mean, let's say, I can use that population mean for x bar. Okay, I think the population mean. For example, here the collection of all monkeys in the Amazon forest has a the mean weight, right? Average weight. We don't know that is what, but it exists. So that let's say x bar. Okay. Now the law of large number states that xn bar, right? This sample mean, converts to the population mean in probability. So what do you mean by this? The sample mean converts to population mean in probability. The mean is this, that the difference xn bar minus x bar, right? This difference should be less than epsilon, right? This event probability, if you make, so this will tend to 1h and tends to 2. And this is answer, right? So what you can say that, so how you can express this, that if you consider a sample from a population and if you calculate the mean of the sample, then that mean tends to the population mean. You can say that the probability, high probability, right? This is exactly here. This is right. So you cannot say that except directly like convergence of a real number, real sequence to a number. Then in that case we did not use the concept of probability, but here we have to express in terms of probability. Okay. Right? So this is where actually the statistic can be explained in terms of probability. Right? Although you all learn the statistic in different way in your elementary school, but if you want to study statistic theory, properly, you have to involve the probability theory. And I think one of the best example, the law of large number. Okay. So what we did here? So we did get the statistic, right? So statistic means you have a population. For example, I am considering the collection of all monkeys in the Amazon forest. Now we want to survey the weight of all monkeys. It is practically not possible because huge number of monkeys is there, right? So what we can do, we take a sub collection of monkeys, then we get what the sample, then we calculate the sample mean, and then naturally the sample mean we can use as the approximate of the population mean. So how do you express mathematics? You have to take the help of probability theory. The best theory is here, the law of large number. The sample mean converts to the population mean. In probability mean, the sample mean which is very close to the population mean, has high probability. I mean this actually. And this theory invented by Bernoulli, and this is very beautiful theory. It connects the probability and statistic, or otherwise you can say that statistic can be explained by using, or by taking the help of probability theory. Hopefully you understand. Thank you so much. See you in the next video.